We are Team 7, and we designed and built the Granular application system for ATV. Today, Adam Paulson, Brett Moore, Carson Cooper, and myself, David Herrera, will be presenting. Our advisor is Professor Metzger.
So the Salt Lake City Mosquito Abatement District came to us hoping to improve their current pesticide dispersal system on their ATVs. Their current system is a spinning disc dispersal system meant for agriculture, not for pesticide, having a swath of only 9 feet. The swath is the width at which their system can spread the pesticide. It is heavy and breaks the ATV racks unless they modify the ATVs and the structure. And because it's a spinning disc system, they have no control over which direction the granule is being spread. Due to this open system and the wet conditions that they work in, the granule in the open system clumps, which clogs the system.
They gave us their pipe dream of a 40-foot swath, which later in the presentation we will show that we exceeded. They also wanted an adjustable gate for a more precise pesticide metering, and they wanted to be able to control the direction the pesticide is distributed. As an example of that, if they are between a field and a road, they want to disperse the pesticide only onto the field and not onto the road where it would be useless. They also wanted a water-resistant hopper because, as you can see in the image on the right, when water gets into the hopper, the granule clumps and is difficult to get out of the hopper. They also wanted to reduce the weight of the system, as the current system is quite heavy. And they want the system to consist of parts off the shelf because they need replacement parts to be available to them.
The solution that we developed is to use air instead of a spinning disc to distribute the pesticide out to and beyond the client's requirement of a 40-foot swath. The ATV electrical system limitations discouraged the use of electric blowers and necessitated the use of a 2-stroke gas blower to achieve high enough air speeds to propel the pesticide. A custom-built valve is used to precisely meter the pesticide. The image on the right shows the internal view of the valve, which represented numerous engineering challenges. The valve is cable actuated by an index turn handle, which moves a cone up and down to increase and decrease the rate of pesticide flow. It's spring-loaded to the closed position, preventing pesticide spills in the event the valve is damaged. Other components include custom 3D printed ABS parts, CNC plywood base, waterproof hoppers and lids, and other hardware store components, which are shown in detail in the following video. The heart of the system is a Stihl commercial leaf blower, which puts out 444 CFM of air. The air comes out of the blower into custom-made ABS, Y, and elbow, which then passes the air underneath the hopper and out the nozzle. The hopper is designed to be easily removed and installed so the operators can change the type of pesticide easily and quickly. The valve inside has been designed to be very accurate in the amount of pesticide it distributes into the airstream by dropping a cone in and out of an exit hole. The hopper is waterproof to prevent caking and clogging of the pesticide when it's raining or flipping up water in their operating environment. The custom nozzle, which is printed in carbon reinforced nylon, is designed to be easily removed for cleaning, as well as to throw the pesticide as far away from the ATV as it can while keeping consistent coverage of pesticide behind the ATV. The entire system is mounted to a piece of CNC'd plywood, which is coated in truck bed liner to protect it from fuel and water. The hoppers are mounted securely to the base with galvanized unistrut, which is corrosion resistant and very sturdy. To protect the rider and the system from exhaust fumes and heat, a metal shield is installed between the duct and the exhaust.
On the right, we have the computational fluid dynamics study performed. This helped us optimize the flow and remove stagnation points in the ducting. It also allowed us to predict the exit velocities out of the nozzles. And as you can see in our results, we did achieve a 40-foot swath with a plus or minus 2 feet in some instances. Dispersion on each side was achieved, and we can shoot from either side of the ATV. We did reach the 180-degree coverage behind the ATV as requested by the client. We also reduced the system weight to 36 pounds, originally from 56, due to the usage of lightweight parts such as plastic. And this final prototype was delivered to SlickMath for field testing during the mosquito season that is about to start. And now we have a demo of the final prototype in action as demonstrated by Adam. Here the operator will be installing the easily removable hopper. SlickMath uses multiple types of pesticide, so this will allow them to quickly swap between them. The hoppers were also set at a reasonable height, so most operators can easily refill the hoppers as needed. And in this demonstration, the granule used is the more commonly used corn cob. After this, the operator will close the hopper with a screw-on lid, which has the built-in gasket to avoid water ingress. The operator will then start the blower system first, and then open and adjust the flow rate gate by using the adjustable handle, which is easily accessible. As you can see, there is a nice consistent spread, and we achieved the coverage out of the nozzles. And in this scenario, the operator chose to only spread granules out of the left side. We want to thank you for your time, and now we can answer questions regarding the project.